In the image, notice how the divers look like shadows and how around the edges of the photo the water is getting darker even though the day appears to be bright and sunny at the surface. As you know, light needs to travel from an object to your eye in order for you to see it. Since there is no light reflecting off the divers, they appear black. Since light is energy, it cannot disappear, but if we aren't seeing it, then where is it going? In photograph number 1, light is obviously coming through the window because you can see objects that are outside, but light is also reflecting off the window because you can see your own reflection. As you can see in picture number 2, someone can obviously see into the window from outside. If the angle of incidence is nearly zero, that is, if you're looking directly into the window, most of the light travels right through the window and very little is reflected. As the angle of incidence increases, more light is reflected in the window and less light penetrates the surface and is refracted. Some light reflects and some light refracts at a surface between two media that have different indices of retraction. This is partial reflection and refraction. If we're on a boat and looking into a lake, why can we see into the water directly below us, but not below the surface as we look further away? Before we can answer that question, we have to talk about the critical angle. The first ray of light travels out of the water after being reflected off a fish and bends away from the normal as it exits. The light is traveling from a denser medium to a less dense medium, so we can look into the water from our boat and see a fish. As we drift away from the fish, it becomes more difficult to see and then seems to completely disappear. That is when the ray of light has refracted off the fish and now travels parallel to the water's surface. The further out from the boat we look, the less we can see under the surface, and the water appears black. This is because there is no more light reflecting out of the water, and we have an example of total internal reflection. The size of the critical angle depends on the indices of refraction of the two media. When the angle of incidence is larger than the critical angle, the angle of refraction cannot get any larger because the refracted ray would no longer be in the second medium. So, at angles of incidence that are greater than the critical angle, no refraction occurs. All the light is reflected back into the first medium. Total internal reflection occurs only when light is traveling from a slower medium to a faster medium, such as from water to air.